Alright, this is page 4 of the review. So which of the following graphs represents a system with one solution? Okay, so for a system to have one solution, remember our solutions are always where the graphs intersect one another. Okay, so our example 1 here intersects here and here. Okay, so since it intersects at 2 points, there are 2 solutions. Okay, mine here I have 2 graphs that are parallel. Okay, so that would be no solution because they never intersect. Solution. Okay, my graph here looks like it's just one line. So really, those are right on top of each other. So that's IMS, infinitely many solutions. And our last one only intersects at 1 point. So that's my graph that has one solution. Okay, 11b. Which of the following graphs represent a system with infinitely many solutions? Okay, so again, over here, option 3 intersects at 1 point, so that would just be one solution. My graph over here has a parabola and then a line that never intersects it, so that would be no solution. Okay, my graph over here has 2 parallel lines, so that's no solution. And then my last graph is one single line. Alright, so that's really probably 2 lines right on top of each other. So that's infinitely many solutions. Okay, 12a. So the library is having a book sale. James and Kelly purchases are listed in the chart. Set up a system of equations to find the cost of each type of book. So this is nice because it already tells us that we want to find the cost of each type of book. So I know I can call X the cost of a hardcover, and I can call Y the cost of a paperback. Okay, so I know if I bought 3 hardcover books, that I don't know what the cost is, so I can write that right in the table. 3x, don't know the cost, plus 2y, the cost of each paperback, it's going to equal $16. And same thing, Kelly bought 1 that we don't know the cost, plus 5 paperbacks at the cost of y. Okay, so my system of equations, when I have this table, goes straight across like that. So it's 3x plus 2y equals 16. And 1x plus 5y equals 14. Okay, so that's part A, set up the systems. Now I want to actually go ahead and find the cost. Alright, so when I have 2 equations here in standard form, I'm going to use elimination. Alright, so I know I need to multiply one of these equations by something so that my x's are the same but opposite, or my y's. This one's going to be easier just to do my x's. So I'm going to multiply each side by negative 3, okay, because that's going to give me my x's 3, and then here will be negative 3. So I'm going to go ahead and multiply negative 3x minus 15y equals 42, negative 42. Okay, then I'm just going to rewrite this one down here so it's nice and organized. 3x plus 2y equals 16. Okay, so now my x's are going to cancel, which is what I'm trying to get. And I have negative 13y equals negative 26. Because I'm just adding straight down. I'm going to divide each side by negative 13, and I get y equals 2. So I know that the cost of a paperback is $2. Okay, now I also need to plug this back in for a y in any of these equations. I can use this one or this one. Since this is 1x, I'm going to pick that equation. And I'm picking the original, not one that I multiplied. Okay, so I have x plus 5 times 2, because I'm plugging in a y there, equals 14. Okay, so x plus 10 equals 14. And then I'm going to subtract 10 from each side. So x equals 4. So hardcover equals $4. Alright, so C says if Kelly goes to the sale with $18 to spend, what is the maximum number of hardcover books that she can purchase? Alright, so we want to know the maximum number of books. Alright, so for my equation now, X is going to equal books. Okay, and I know that those books are $4 each. So 4X equals 18. So I'm going to divide each side by 4. And I get X equals, use my calculator here, 18 divided by 4, 4.5. Okay, so I don't want to round 4.5 and say 5 because I don't have enough money to buy 5 books. Alright, I wouldn't have enough. So I need to round this one down. Usually whenever we're looking at these type of problems, usually we're going to round down. I cannot buy a half a book, so the total number that she can buy, the max hard cover books is 4. Okay, 12B. Okay, so a sushi restaurant offers 2 sizes of rolls, small and large, and listed in the chart below. So we need to set up a system to find the cost. Okay, so again, X is going to be small. Y is going to be my large. Okay, and I can go ahead and plug it right in the table here if I want. Alright, and then I'm going to rewrite it over here. 3x plus 5y equals 56.5. And 4x plus 3y equals 46. Okay, so again, I have it both set up in standard form, so I'm going to want to use elimination. Alright, but I need to multiply each equation by something so that my x's and y's can cancel. And they could be different, because obviously I can't just multiply one, and I don't want to multiply them both by the same thing. Alright, so I'm going to start with my top equation. Okay, I know that my least common multiple between 3 and 4 is 12. So I need to get those to be 12. So I'm going to multiply the top one by 4. Okay, and I'm going to put that over here. Okay, so 4 times 3 is 12x. 4 times 5 is 20y. And 56.5 times 4 is 186. Okay, so now I know I want this x to be negative 12x. So what am I going to multiply 4x by to get negative 12? I need to multiply it by negative 3. So I get negative 12x. Negative 3 times 3y is negative 9y. And negative 3 times 46 is negative 138. Okay, now I can go ahead and add down. These are going to cancel. 12 minus 9 is 11y. And 186 minus 138 is 48. And I'm going to divide each side by 11. Looking like I made a mistake. Okay, I'm going to go back. 4 times 56.5 is actually 226. Okay, so now when I add down 226 minus 138 equals 88. Okay, now I'm going to divide each side by 11 here, and y equals 8. Okay, so I know that a large roll equals $8. Okay, so now again I'm going to go pick any equation here and plug it back in. So I'm going to pick this one here. So 33x plus 5 times 8 equals 56.5. Okay, so I know 3x plus 40 equals 56.5. I'm going to subtract 40 and get 3x equals 16.5. And 16.5 divided by 3 is 5.5. Okay, so a small roll equals $5.50. Alright, so if Jen has $50 to spend, what is the maximum number? So again, x equals the number of large rolls. Okay, so a large roll is $8 times the number that she bought is going to equal 50. So I'm going to divide each side by 8. 50 divided by 8 is 6.25. Okay, so can I buy 0.25 of a roll? No. If I buy 7 rolls, that's going to be too many. So she can buy 6 large